All right, so today we're going to be discussing augmented matrices and how they're different from just a matrix in general, and what the general idea is and what some key terms are. We're not actually going to be solving the matrix step by step, but we're going to be showing the idea behind it. So let's say we had this set of equations. 2x plus 2y, 3y, boop, boop, plus 5z equals 0. 5x minus y plus 2z equals 15. Negative 2x plus 3y minus 2z equals negative 15. And so you could solve this the traditional way, that is trying to do substitution or elimination here. But if you've done that, you may have noticed that it's kind of a pain because you have a lot of stuff to keep track of. The variables are moving all over the place. And you can see how pretty quickly, if you had 4 or 5 variables, it might get really unmanageable. But a way you can represent this is you can just pluck off the coefficients. And you can put them in what's called a matrix. Let's see what that would look like. So my first row would be 2, 3, 5, and then I'll put this line here that represents those equals and a 0 right here. Second row would be 5, negative 1, 2, and 15. And the third row would be negative 2, 3, negative 2, and negative 15. Because of this line right here, this is what's called an augmented matrix. If you didn't have the line and you just had some numbers in a grid, that would just be a regular matrix. This one's augmented because we have that line. Now what you would do, we're not actually going to go through the process, but there is a process you can do that would get you down to something that looks like this. And in this case, the numbers on the other side of the bar here would be 2, negative 3, and 1. This is what's called the identity matrix. It's called the identity matrix because if you look at it, it tells you what the identity is for x, y, and z, or what x, y, and z are. Because here the coefficient is 1 on the x, and the coefficient on y and z are both 0. So this first row is basically telling you x equals 2. 1 times x plus 0 is equal to 2. This second row has 0 on x, 1 on y, 0 on z, and then it's equal to negative 3. This row has 0 on x, 0 on y, 1 on z, and it's equal to 1. And so now we have our solution to this system of equations. The solution would be 2, negative 3, 1. So this is what's called an augmented matrix, and the main use of them is to simplify visually what you're looking at, and there's some cool stuff you can do with matrices as well that can speed up the process of solving systems of equations. So this is an augmented matrix. Pluck off the coefficients, throw them in there. The bar represents where the equal sign would go. And you can do steps to get down to where you have the identity matrix, where each row and column have only 1, 1. See this row, this column, there's 1 right here. This row, this column, there's the 1. This row, this column, there's the 1. So that's the main idea and purpose of matrices insofar as you're using them to solve systems of equations. Now keep in mind, you don't have to use matrices to do that. There are other uses for matrices, but for pre-calc, for this particular application, for this idea, this is what they're used for. That is this idea of matrices.